Okay guys, so in this video we are going to talk about microservices, so let's get into it. So what do I mean by cheap microservices? Well, I'm thinking that I want to touch on something that quite a lot of people don't actually consider when they start talking about microservices. All they know is that they should be using them, right? So basically what we're going to cover here is one of the biggest costs of microservices and how to mitigate some of that cost. So basically the problem that you will face is that as soon as you buy into this idea that service-oriented architectures and microservices and stuff like that is a useful thing, you're going to start splitting things up. And you're going to notice something, and that is that quite a lot of the time you need to make a network request or some connection to one service and retrieve the data from that service. Now, what is the difference between that and having everything in the same code base? Well, I'll tell you. You see, now you need to know in the client and in the server or the service that's going to respond to that client what model is going to be transferred over the network. In other words, you have all of this boilerplate code that is necessary that needs to exist on both sides of the conversation, because if you don't have that, you're not going to be able to know what's going to be transferred over the network. An example is if you contact a service that has, say, books. Well, the service who needs to make that call needs to know what a book is to that service, and that means that all the code that is in that service, or at least the model, needs to also exist on the client side. And this is what we call an API interface. You declare an API of some sort that you can connect to, and now it's your responsibility as the maintainer of that service to make sure that everybody who is connecting to that service can trust that the thing that you have stated in your documentation is going to be sent over in the correct fashion so that they can create their own implementation. You would be surprised at how much work this is, because it basically means that if you can imagine yourself, you have maybe 10 different services that all connect to each other. If any of them change, you need to make sure that the other services that depend on that service is going to get updated as well. This is what we call versioning your API, because if you do like breaking changes, or you change something that's going to break code for somebody else, well, you can't really do that unless you want your little service-oriented architecture or your microservices architecture to completely fall apart. So what I'm going to show you now are a few approaches to solving this sort of problem that helps quite a lot. So the first and foremost thing we're going to have a look at here is that I have a few services here, which we're basically a books API, a payments API, and a user API. So let's start with the simplest possible thing first and foremost. Let's start at the books. So here we have our little Express server, and it's all in TypeScript because types are nice. And then we have this thing here, where we just have some endpoints that you can connect to, right? And notice now that you notice that I have this routes module here basically, which is going to pull in the routes to this endpoint. So what's this about? Well, one of the best and simplest things that you can do when you have a distributed system with tons and tons of different services is to start to think about the public models. Now, what do I mean by public models? I basically mean about we need to think about what is going to be necessary information for both the server and the client in a service-oriented architecture. One such thing is going to be the route. So if we think about that, if we put the route information and the models that are going to be transferred over the network in a shared package or some shared repository that they both the client and the server can depend on together, then we are always guaranteed that they both have the same information at the same time. So if in a more elaborate setup, I might have put this shared directory here into my own npm package or something like that, and then they would both depend on this together. So here, if we look at my books directory here, I have a bunch of files here. Let's see, we'll just pull this down here. We'll see here that I basically have all of this information that is relevant for, well, basically for my server. But my client can also use this. So I've created this little function, well, this little object export here that just contains all of the route information, so that if, let's say for the sake of argument, that my books API here, well, we have a dependency from that to some new service, or some new service needs to know about the information that is, well, the routes basically that are inside of this API, they can simply reference the same code. Now this is of course all in TypeScript, but we'll talk about different languages in just a moment. So as long as they're both running TypeScript, they can just depend on this package together, and they can both share this interface, which makes it reduces the cost of having to rewrite all of that boilerplate in the second, like in new services. You can just trust that the thing that is true for the actual server is also going to be true for all of the clients. They will have the same information, right? So one thing that we should really think about here is to do something like this, and that is to define a Swagger file or some type of, well, in this case it's the OpenAPI standard, where we document all of the models, all of the endpoints, and all of the responses that our service can actually declare, or that, you know, we just declare the interface, right? And this is something that we put in our share directory here, and we basically just document exactly all of the endpoints and what they're going to return and all of this stuff here. If you're not familiar with Swagger or the OpenAPI standard, I highly recommend you have a look at that, because in a API-driven world, this is one of the bastions of sanity we have left, because we really want to document our APIs and guarantee that they behave in the way that they are expected to behave. Because trust me when I say this, it is a jungle to work with an API that is unstable or doesn't really behave the way you want. You really want your API to be consistent. And honestly, it's so easy, even as the implementer of a service, to just forget or to change something with, and then, you know, you just don't. It's to get out of sync with an API and the documentation for that API. It is so easy. It's so easy, and sometimes it happens without you even knowing it. So having some type of central documentation which you provide to yourself and to the consumers of your API is absolutely vital. So this is the easy way of doing this. This is it's not as nice as it could be, but it's going to work for us. We basically just declare the Swagger file, and then we just try our best to do something like this. We might write some tests, and we might, you know, things like that. We just centralize all of the, like, you can think of it as just the stuff that is interesting for both the server and the client at the same time. And this means that anybody who depends on this can also trust that they have the same information as the creator of the service. Here I have some models. Basically, this is what you would have expected. So instead of putting, because I could put all of this in my books service here. I could just keep that information here, but thanks to the fact that I'm putting it in this shared dependency folder or whatever, I can actually share it between multiple services, and that's exactly what I want. So now I have this responsibility. I haven't written any tests now, so I should probably do that, but I was too lazy to do that. I'm sorry. But basically what I want to be certain about is that all of these models are in sync with the models that I have created here, and that all the routes are in sync as well, because this piece of documentation is the thing that the consumers of my API are going to trust is going to be true. So I have to make sure that all of this is in sync. And then I have this little client here where I basically just declare a few functions that pretty much just are conveniences, because this is boilerplate code. This is something that every single client, you know, they want to get all the books, they want to create a book or update a book or something like that. This is like, you don't have to rewrite this code every single time. It's much easier if you just declare the interfaces and create some clients, and then you can just interact with the API through the system, right? So this is the low-hanging, the minimal thing we can do. We basically just manually declare all of our models based on a Swagger file or something like that, and put it in a shared place so that everybody can depend on it. However, there is something more we could do to kind of make this a little more robust, because, I mean, we can absolutely just unit test the absolute shit out of this and make sure that everything works in the exact way that we want. But there's also another approach to this, which is code generation or templating or whatever, generating a lot of this boilerplate for us. So if we have a look at the payments directory here, let's shut all of this down here. So no, actually, let's have a look at the actual code first, like the actual service. So once again, we have our server here, and let's see here, yes, and then we have our application. So you see here that it's a little bit weirdly formatted in a way, but that's because I'm a little bit lazy with my formatter or my generator. But then we have this little comment here. So this states this is a generated file. So what does that mean? Well, that basically means that this file is, I didn't write this file. I have a script that generates this file for me. That's all it means. And then we see here that I have something called actions, and what's this? Well, actions, this is not a generated file. I didn't put a comment here. So this is something I actually wrote myself. So this is the glue code that I write in order to connect my concrete implementation of the logic that I want to create, right? And the generated code. That's pretty much it. This will make sense in just a moment, but basically these are my action handlers that you can see here that create payment. All this is going to do is that it's going to take in, well, as you can see, this is just a request handler, and I wrote these by hand. So here, this is where I would like put all the logic, right? This is where I would do all of the logic of the operation, and then I have something called response sender, which calls create payment with the response for some reason. Let's look at that. So why do I have this thing called response sender? Let's look. So response sender. So here we can see this is also a generated file. So my response sender has been generated based on some specification. And the reason why I want to do this is because I have declared an API of some sort. I have decided that, all right, these are the requests that are valid to send to this endpoint. This is the route, and this is the response code, and this is the body of the response. I have just declared all of this stuff, right? And if I can declare that in a fashion that makes it possible for me to generate my code based on that specification, I can actually save myself a lot of hassle. Because I mean, in the first scenario, although it's easier for me to just manually write all of this by hand, it's a little bit of a problem as well, because now I really have to make sure that I'm not by mistake, like by mistake I could just forget to set the status to 200 or 201 or whatever. I could do that, right? But if I generate my code based on a written specification, I can never get to that point, right? And that's why I have this response sender that takes care of that, acts as it basically just makes sure that the response that I have declared in my specification stays true, so I don't make a human mistake here. So what is this response, or this definition? Well, this is my definition. So this is not a Swagger file. I didn't actually create this. I could do that as well. I considered it, but it was a little bit more work than I wanted for this little demo of mine. So I could use this manually. This is like my own format. This is me, Frederick, inventing this by myself, but it's similar to approaches that I've used in the past as well. So I could use this to make a Swagger file as well, which I probably would want to if I wanted to have Swagger documentation for this payments API. So let's just walk through this. So I have an object, and it has some routes, and then there's like a bunch of routes here. So I declare a path, some methods, and then there's an action here that is called something, which is list payment, and that has a response, which is going to return 200, and then I have a body, which has a ref. So this is just a specification for me to be able to reference an element within this document so that I can actually inject the list payment response interface value into this position, so I can get some reuse, because I don't want to have to copy paste everything, which is a bit of a hassle. And here we can see this continues here, and here I have some schemas. So I have my list payments response, which is declared to be a model, and then there's the name, and then the interface name, and here are the fields of the interface, and it just kind of goes on here. So you can invent your own standards, of course, and there might be nicer ways of doing this, but this is the simplest thing that I could think of. So I've just created my own specification. This is my API, right? And thanks to that, I can now do something like this. I can have my little script here, which I call generate, charmingly enough. And then I use ref parser, which is just something that's going to return. It basically converts all of those references you saw earlier into the value that I'm actually referencing. And then I'm going to get my definition. And here I have a bunch of generator code that just reads in a bunch of templates, which we will look at in just a moment. And as you can see here, all it does is that it spits out my various files. Now this is all in TypeScript, but the strength of this is that, let's say for the sake of argument, that you had an API which you wanted to provide multiple clients to. So let's say that you have some people who say, yeah, we really want an SDK for this API that you made. Could you make one for TypeScript, one for JavaScript, and one for, I don't know, Go, one for whatever language. It doesn't really matter. Any language is valid here, right? So that's what's pretty cool about this, because if you define your API through this, I mean, this is just JSON, then you can create generators or write your own generators, or use, there are tools for this as well, but this is the simplest thing that I could think of, and just spit out that glue code, like all of this boilerplate that everybody needs to sit and write, which is, as I said, that code that is shared between the client and the server. In other words, the route, the responses and the requests and like the models that go over the network, all of that stuff can be generated, which saves quite a bit of time. So here we can see that, say, let's look at my models here. So this is a generated file, and based on my little template script here, I basically just, whenever I change this file here, I can basically change this file at any point and change the status or whatever, and then just run my generator script again, and it's going to reflect in the update and update all of these models. And then whenever I do that, of course, I will make a new release. Like in an NPM world, we would simply create a version 1.1 or 2.0 or whatever, depending on how much we changed, and then republish that package, which means that now whenever, if the consumers of our API, they want to have these new, like the updated version, it's very simple for them. Like they don't have to go themselves and like update a bunch of code. Basically all they have to do is to depend on the new version of our published package, right? Which makes this quite easy to maintain. And that's a big time saver, especially when you want to make sure that everybody is on the correct version of your APIs, right? Because you don't want to force people to rewrite their code just because you needed to make a change, right? And here's a generated client that just injects all of the stuff that is needed, and this is code that doesn't have to be written over and over. You can just have a script that generates it. And in this case, these are my template files. So here I use handlebars for this, to basically just, as you can see here, this is just a text file where I use handlebars to pretty much just express the template that I want to generate. Same thing here, just a template that spits out all of the code that I want. And the same thing goes for models. This is a little bit, this one gets a little bit more messy, but basically that's what it does. And then all I have to do is to update this definition file whenever, and ask for feedback or whatever whenever I do this, so that everybody's aware of that this is now updating. And then I just run this script and it spits out all of the new stuff. So adding new clients or creating new models or new routes or whatever is as simple as just updating this file, and then I just generate all of that code. So that's a pretty useful thing. Now, one thing that is a little bit special, I mean, here where I'm using handlebars to do the templating, you don't have to use handlebars. There's just like, you could do something simpler. I have one example here from my users API as well. Same thing here. I have a service definition file of some sort, which is just, as I said, this is just me. This is something that makes sense to my services. And I declare all of my schemas, and I declare like my routes and my methods and all that good stuff, right? And that's about it, right? And the same way it works the same way here. So this is a generated file that just gets generated whenever I run my generate function or my generate script. And here are my models, and here are the clients, and then here's the script. This one is a little bit shorter because here I'm actually just using templating, and that's pretty much it really. So I have these functions that takes in the definition file or the definition object that holds all of this information here, right? And then I created a generator here where I just basically use template strings from JavaScript to generate all the code that I want. And the same thing goes for here. I have some out-commented code here from the old files. Oh well, it doesn't matter. And the same thing goes here. So you can kind of pick your preference here. This, I think, it gets a little bit arcane sometimes. You can do this in a nicer way, I'm pretty sure, but this is a fairly simple demo, so hopefully I don't have to kill myself with creating really pretty scripts. But yeah, this is pretty much the approach. So this is we use a similar approach at my job, where basically we define our specification and then we can generate these boilerplate models based on those specifications. And I highly recommend you to have some type of strategy for this. This is like just two different approaches of doing this. Doing this. Like, if you want to keep it simple, just write it by hand and make sure that you have unit tests and like integration tests to cover all of the different things that you have declared in your Swagger file. But if you want to go a little bit further using something like code generation and like generating your clients and your models and your routes and all that stuff based on some text or JSON, it doesn't have to be JSON, it can be any specification. Just parse the file and spit out that boilerplate code. And that should be and then you should be pretty much set up. So hopefully this was useful to you. Remember, when you're doing microservices, you spend quite a lot of time writing glue code for these different APIs to talk to each other, and it's always a hassle to make sure that you didn't make any breaking changes. And this is just a fairly nice approach, in my experience, to share models and clients and like all of this stuff between different services and have everything kinda low maintenance. So yeah, I hope you found this useful.